So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CAIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamualaikum warahmatullahi wabarakatuh. Welcome to another physics lecture. So today we are going to start our discussion on section 2.3, that is the transfer of heat energy. Before that, we need to know what exactly is temperature. Temperature is a measure of the degree of hotness or coldness of a body. Thermal energy may be transferred from one store or one region to another region as a result of a difference in temperature, and this can occur in three different ways. One is conduction, second one is convection, and the third one is radiation. These are the three types, or these are the three methods of transfer of heat energy. Thermal energy flows from a high temperature object to a lower temperature object. However, this will cease when both objects reach thermal equilibrium. They are at the same temperature. When heat is being transferred from one object to another object, as soon as both objects reach a same temperature, the heat transfer will stop. Two objects in thermal contact are said to be in thermal equilibrium if there is no net heat flow between them. In thermal contact, what is thermal contact? The hotter body becomes cooler while the cooler body becomes hotter or warmer until a point is reached when no more change occurs. The two objects are said to be at the same temperature if they are in thermal equilibrium. Objects does not have to be touching one another to be in thermal contact. Two objects are said to be in thermal contact when they can exchange heat energy between them, and they may have some physical distance between them. For instance, Earth is in thermal contact with the Sun, even though Earth is obviously not touching the surface of the Sun. Hence, the real systems are always in thermal contact and not necessarily in physical contact. Thermal contact does not mean thermal equilibrium. If that was the case, then Earth would have been at the same temperature as the Sun by now. So the first method of heat transfer is conduction. It is the transfer of thermal energy from one place to another without any flow of the material medium. The material or the medium does not change, does not flow, does not move. It rather just transfers energy through vibration. Metals are usually very good thermal conductors, whereas non-metals such as plastics, rubber, etc. are poor thermal conductors. They are rather known as thermal insulators. Conduction typically requires the object to be in physical contact with one another. How does conduction works? Basically, in solids, atoms or molecules vibrate about their fixed position. When thermal energy is provided to them, the hotter they become, the more vibrations they have. These molecules collide with their neighbors and transfer some of their kinetic energy to them. The neighbors collide with their neighbors, and so on. This continues until kinetic energy or thermal energy is transferred from a region of high thermal intensity or high temperature to a region of cold temperature. This is a very slow process. Solids conduct heat better than liquids and gases due to their closely packed molecules. Another method of conduction is free electron diffusion. Most metals are known as thermal conductors due to their huge number of free electrons available for thermal conduction. What happens is that metallic lattices have free electrons in them. That's why they are able to conduct electricity as well. So when heat energy is provided, those free electrons pick up the heat energy and they start moving very fast throughout the lattice. This is known as free electron diffusion. In solid thermal insulators, there are no free electrons available, hence the object is restricted to conduct thermal to perform thermal conduction. It basically restricts the thermal conduction just to the vibration of atoms and molecules only, which is within the crystal lattice, which is a very slow process. Whereas the free electron diffusion is, on the other hand, very quick process. Normally in typical metals, both of these atomic collisions and free electron diffusion are happening simultaneously. That is why metals are able to heat up very quickly. Application of conduction, or you can say uses of conduction. Cooking pans are made with metals because of their good thermal conduction, so that all of the heat or the flame can be transferred to your food. In contrast, handles of such utensils are always made with an insulator so that your hand does not get burned. Sawdust is used to cover the ice cubes from melting, as sawdust is a good insulator. The second method of heat transfer is known as convection. This usually occurs in fluids. Now a fluid can either be a liquid or a gas. Convection is the transfer of thermal energy from one place to another by means of bulk fluid movement. In fluids, thermal energy is transferred mainly through thermal convection. In solids, since its substance cannot flow, there can be no thermal convection. Convection is basically the spread of thermal energy through flow of a fluid or through currents of a fluid. By currents I mean waves or the movement of particles of a fluid. How does it work? The movement occurs as a result of gravity. The hot part of fluid expands, it becomes less dense and rises up. It is displaced by the colder, denser part of the fluid, which in turn is heated up. This forms a cycle and it allows heat to be transported evenly throughout all of the fluid. Application of convection. In a refrigerator, convection is used to circulate cold air around the food. Air is cooled by freezer compartment at the top of the refrigerator. As it sinks, it is replaced by warmer air rising from below. The circulating air carries away heat energy from all the food in the fridge, lowering down the temperature of the food. Then we have the third method is supposed to be radiation. It is the transfer of heat energy from one place to another by means of electromagnetic waves or radiation. without the need of an intervening material medium. Now, conduction and convection both require a medium to take place, whereas radiation does not require any medium. All matter radiate thermal energy in all directions in amounts determined by their temperature. When the energy is carried by photons, such as the infrared, visible, and X-ray portions of the electromagnetic spectrum, these photons warm up anything that absorbs them. Basically, radiation can be considered as a ray of electron that is photons that is emitted by a hot surface or a hot object in all directions. Now, whenever an object is there in the path of the photon and that object is able to absorb those photons, then radiation occurs, or the transfer of thermal energy occurs. Radiation is the only process that does not require a medium to transfer the heat energy. Factors affecting the rate of radiation: the color and texture of surface. Black matte surfaces are very good in both absorbing and radiating or emitting radiations, whereas white surfaces are very poor. That is why we are more comfortable wearing white clothes in summer and black clothes in winter. Shiny or polished white surfaces are poor absorbers because they act better as reflectors, hence they are poor emitters. The surface temperature of an object: the hotter the object, the more energy it radiates. The surface area: the greater the area, the more energy it radiates. For example, the sun has a greater surface area, so it radiates more heat energy than any other object in our solar system. Applications of radiation: the greenhouse effect provides a mean to grow plants that need a warm environment in cold countries. Short infrared radiation from the sun passes easily through the glass panel of a greenhouse and is absorbed by the plants and the soil inside. The plants in turn radiate energy, but with a much longer wavelength. This radiation is reflected by the glass panels being trapped inside the greenhouse. Hence, the temperature inside the greenhouse increases until it reaches a thermal equilibrium suitable for plants to grow. A layer of aluminum sheet is placed below the roof tiles to keep the air temperature inside the building steady. In the day, the aluminum sheet reflects the radiation and keeps the building cool. In the night, it reduces emitting radiation from the inside and keeps the interior warm. An example of transfer of heat energy is a vacuum flask. It can store and maintain temperature of either a hot or a cold liquid or solid of the contents in the flask by reducing heat transfer in or out through conduction, convection, and radiation. Now, vacuum flask is an instrument that relies on all three types of heat transfer. How does convection work? Vacuum between the double glass walls of a vacuum flask prevents convection, heat loss due to convection. Then vacuum between the double glass walls, as there is vacuum and no molecules present, it also stops conduction from occurring. Whereas the shiny silver inner surfaces of the glass walls, as they are silver or closer to white color, they prevent or reduce radiation from being emitted outside the flask. Hence, the content inside the flask is able to remain hot or remain cold, as the reverse also occurs. No radiation is able to penetrate through the shiny glass surface inside the flask, and all these three methods prevent the vacuum flask from cooling down or heating up too quickly. Example question: figure 5.1 shows an X-ray tube. In the production of X-ray, the target gets very hot. Thermal energy must be removed from the target. The tube has several design features to enable this to happen. For each of the following types of heat energy, describe how the design of the tube increases the rate of energy transfer. State where the thermal energy transfer mostly happens, the design feature that increases the rate of this, and a brief explanation. This is the X-ray tube. Now, how does conduction occurs? For conduction, where it occurs inside the rod. When the high-speed electron beam hits it, the molecules inside the rod vibrate faster and faster, colliding with the other molecules, spreading the heat from here till the end of the rod. Feature, the thickness of the rod, or it being made up of a metal or copper. Have they mentioned copper? No. Okay. Metals are a good conductor, thus it increases in the amount of conduction from target to end of copper tube towards the fins. I might have missed this line. They have somewhere had they have mentioned there is a copper rod. This is a copper rod, so you can directly mention the name of the metal. How does convection occurs? Convection would occur inside the fins. The passing air would heat up due to the heating of the fins. It would rise up. Colder air would take its position, take more energy, heat energy from the fins, and the cycle would continue over here near the fins. And what are the design features of the fins that help it? Large surface area, a large number of fins, the spaces between the fins, which allows convection to occur. It has large contact area with the air, thus it allows air to rise between the fins. This passes on the heat from the fins to the air around. Now, how does radiation occur? In the fins, where it is having the black color, or the end of the rod, the black surface or the large surface area radiates heat energy. Why? Because black color is with a very large surface area would be a good emitter of heat to the surrounding. This is it. That's everything you need to know in section 2.3. I hope you have understood everything. If you have any problems, feel free to ask me, and I'll see you guys in the next lecture. Take care. Allah Hafiz.